how can you say start? Yes, start is first. Hi guys, hi engineers and others. This is Sanjay Suraj Singh speaking from Bharat, India. This is the second video of this series today because last was this time this is document share. I am sharing a screen for one technical report, one investigation report, and also some parts of FIDIC, and that's contract conditions, standard contract conditions. That's there we are going to share with you. This is a PDF files. There's only PDF files can be shown. I can't use other files in that, so I'll discuss something about soil as usual I do, and that's very important one, important point, and soil, and that's very important one factor level of light first of all, because I'll then because I can't show my face in this. This is a document share, and I am going to discuss with you about this is continuation to previous one. I showed to you many times these documents, these reports, technical reports, soil investigation report, and now again I am trying to connect you to that, as well as to certain talks on. You can see these are files here. This is files of this one, and this is files of this one. You can see this is file. You can see this is file FIDIC, and that's this is contracts file, and I discussed with you last time about these conditions in that, and you can say that these conditions I showed to you last time, and this is a file, that one. So this you can say this file is here, and this file means you can say like I'll talk to you about many conditions of, you can say, test on completion. Before that was showing I should fast move, and this is I showed to you something like commencement delays and suspension. Yes, I was there in that one. In that one I was there. So now I'll talk to folks. This is certain tests that we are doing. That's here. Now what actually this says, you can say, I discussed with you all this, this context of contents is just 20 contents are there, 20 sections are there, and 21 actually. Once last one's arbitration, so you can section number 1, that's clause number 1, you can say. So introduction, then 2 is project description, 3 is site supervision, 4 is say prevailing conditions, and 5 is general geology of area. All this is shown in this, and this is about this reporting, general geology of area, field exploring and testing, and all that. Then laboratory testing, surface and subsurface conditions, and then this is about soil report and general discussions for choice and suitable foundations, and conclusions and recommendations. And then another one has 21 clauses, that is for FIDIC. This is technical reports from a laboratory. So both are, one is technical and is context, so don't confuse. And the other one is I'll start with this. All these are there, all these are shown to you, these reports, and there are certain attachments also which are very interesting with local. We are discussing the location of boreholes and trial pits, and then logs of boring and trial pits we discussed, and field test results, etc. We did not discuss completely. So I'm not considering which company, so I'm considering technical requirements. That's soil samples, just test of particle size analysis, materials passing through 200 cm, moisture content, atomic limits, modified Proctor, California bearing ratio, lab thermal resistivity, permeability, chemical analysis, including you can say determination of chloride content, sulfate content, pH, calcium carbonate, and magnesium, oil and grease and petrochemical, the petroleum hydrocarbons. Then in ground is chemical analysis, and including determination of chlorides contents, sulfate contents, pH. I think there's nothing as such. How is happening here? Camera come here. What's the camera? Why it's not taking? I don't know. What's that? How is happening? There's no camera. What's camera? None of cameras documents, I think. This document, how can you depend on camera on this? See, is it? Yes. It's groundwater now, saying groundwater. So groundwater is not check down. Groundwater is, it's not groundwater. It's not, yeah, it's groundwater. Chemical analysis including determination of chloride contents, sulfate contents, pH and magnesium, oil and grease and petroleum hydrocarbons, performing engineering analysis of field and laboratory findings, developing conclusions and recommendations for design and reporting. Uh, so it's sharing. Well, why people are sending this here? I'm fed up with these people. I should talk to them. I should talk on this. It's really very, very serious issue. But people are not serious. They're not serious. They don't allow to work. Unfortunately, I don't like it. So chemical analysis including determination of chloride content, sulfate content, pH and magnesium, oil and grease and petroleum hydrocarbons, performing engineering analysis and field and laboratory findings, developing conclusions and recommendations by design and construction and reporting. And then you can say project description there is, and if you see that one, you will find that project description. So it's coming here, and this is what I can say. And project description says that whatever project description means, site description is there about this. We go further. Prevailing weather conditions. These conditions are because it's happening. Gulf, just briefly, I just tell you. Site is situated in Arab Dabla, where hot and climate prevails. Hot and climate is one where evaporation exceeds the precipitation. Hot means evaporation exceeds precipitation, such as rain and dewfall. This climate regime produces characteristics hot desert terrains. Average annual rainfall may only be a few centimeters, even only a few millimeters in some parts, which usually occurs seasonally and sometimes only from a single cloud burst. Summer shade temperature are frequently in excess 40 degrees Celsius, and humidity may be around 100%. Near coast, coast is coast, COST. A contrast between maximum night and day temperature and between night and day humidities is often great. Strong persistent winds are normal in many areas. This unfavorable climate imposes adverse conditions on concrete structures such as high temperature and high seasonal changes, high humidity and high changes in relative humidity, strong dry winds, condensation at night, windborne, salt-laden dust, high solar radiations. Then general geology of area, so that's another one point. General geology general geology of area, and that's that one. Abu Dhabi, is a coastline of Arabian Gulf, and folks and developed a geomorphological model division of mountain long back, and so we do not go further. And we talked of this field existing ground levels. We discussed all that. We also discussed we discussed about field, all these tables. I discussed about borehole logs, which I think, and also there's a laboratory test that we in order to determine physical, mechanical, thermal and chemical properties of ground material. Laboratory tests were performed on selected samples from borehole, trial pits and from existing surfaces. Laboratory test results are prescribed now. Which are those? Moisture content according to whatever it is. Grain size analysis minus number 200. C analysis too, and then attributes limits of soil, and then modified product according to this one, and the California break ratio, CBR, and lab permeability according to that. Soil thermal resistivity, water soluble sulfite contents of soil and sulfate content of soil, and water soluble chlorides content of soil according to this, and calcium carbonate contents of soil, and magnesium of soil, according to the oil and grease and petroleum hydrocarbons, pH value according to the classification of soils. For engineering purposes, a description of soils according to this, and codes, and then we have to material, physical, mechanical, and thermal properties. You can say sieve analysis and atomic limits. That results were used to classify soils and ununified soil classification system. So material, chemical properties, sulfate contents, chloride contents, and others, and pH. Like that, we move general discussion for choice of suitable foundations. We did. Then we had to move further down, and conclusion and recommendations, foundation Jackson type we did. Then tank foundation hydrostatic testing, this we did also. And then alluvial bearing capacity for shallow foundations, that we did now. Then we had also gone to this, this is alluvial bearing pressure for different areas, and this we had gone clearly. I think we had gone all this. I think we have gone on left, I'm not sure, but we will discuss with that. All this, we just have a review look so that you can read that, it's better. That's a review of this. No, it's wrong. So this is allowable bearing pressure for different areas at different depths and different water. We had discussed about this, all boreholes, and we have discussed about foundation depth in various, during bore logging and design aspect value are different. Then subgrade metals, which is that, and narrow bearing capacity of 1 meter, 2 meter, 3 meter, 4 meters of this ones. Different areas of that means allowable net allowable pressure for footing with on this is, and modulus of grid we studied, and then also modulus of elasticity and shear modulus. We had seen that the static and dynamic are different, about 75% difference is there. I think 75.7. I think, and this shear modulus we saw difference for all this, and it was we just understood that well in all these cases. And same notes are there, no different noting is here. And noting says a net well bearing pressure value of 1 kilogram per centimeter square for design of isolated footings, strip footings, and value of 2.5 kilogram per centimeter square for design of raft foundation on thick engineered fill are recommended. So thick engineered fill are recommended, that's the important one. And then let us say I'm sorry, gastric, let me pull off this battery also for half an hour, so that battery to rest sometimes so what what's happening? So tolerable settlement for isolated stiff footing is 25 mm and for raft is 50 mm. Modulus of subgrade erection was calculated considering 25 mm settlement and factor of safety 3. Excavate to 2 meter depth and construct engineered fill to foundation depth as item number 10.1, and plate bearing test shall be carried out at foundation level to confirm allowable bearing pressure and settlement, and these net allowances bearing pressure may be increased by 30% for all transient loads such as wind, transient loads such as wind, seismic or short-lived, short-term operating loads. This is transient load, not persistent load. Then this all separate boreholes we discussed one by one, and also we evaluated these according to our own understanding. I think these are all 28 boreholes we discussed, and then we are here. I'll move again. Rotate this. I rotate this as well. Again, I forget how to rotate this. Clockwise it is. I use clockwise here again. And so it's this, yes, and it is, this is representative compression wave and shear wave velocities. This is very important from our point of view, because we have to understand this shear wave velocity and compression wave. What does it say? It says material type, and we discussed this also: unsaturated sand and saturated sand, and unsaturated sand and gravel, and saturated sand and gravel. Now, represented compression value, that is velocity, is called meters per second, and shear wave velocity is also in meters per second. Let's take some water there. Now, in unsaturated sand, representative compression wave is velocity is meter per second, which is 200 to 1000, and that is 8. And then shear wave is 80 to 400, so 40% of that is understood. We thought that way. And in saturated sand, representative compression wave is 4 times of original one, that's 800, and 2.2 times out of the maximum one. And this, as you can say, here is 4 times, that's shear wave, 80 to 320 and 400 to, so 2.2 times that side, and here also 2.2 times. So you can say that compression waves is 200 to 1000. In that case, shear wave is 40% of that. The representative compression wave velocity is this, and shear wave velocity is 40% of that. And its saturated sand is, if we compare to unsaturated one, in saturated sand it's 4 times a minimum one. 4 times means saturated sand means water. It's because of water, because of compression velocity is affected by water distance, and shear velocity as well, because it's also 4 times. That's 200 to 800, 880 to 320. 1200 to 20 is 1.2 times more. So here also 1.2 times more. Then it's unsaturated sand and gravel. Unsaturated sand, when sand and gravel is unsaturated sand and gravel, it's higher than that, so it's twice than sand. That is, unsaturated sand alone is 200, and with gravel is 400. So there is half in case of this minimum one, that is 400, 500. That is, gravel means maximum staking in lower one's case, and when it is shear velocity is also means 160, that is half of other one. So then you can say double than unsaturated sand, and the gravel comes in, it impacts on velocity. Same thing is down one. For this saturated sand is 500, it is less than that. And here unsaturated sand is more, but saturated sand and gravel is 500, it's less than previous case. Now this is based on Vs. Here it says based on Vs is equal to 0.4 Vc, that is, Vs is shallow velocity, shear velocity is 0.4 Vc for soils. So now foundation subject to vibrations. It's very important now Vibrations, foundations subject to vibrations. That's really interesting one. Foundation subject to vibrations. Every is subject to vibration. Reciprocating engines, that is compressors, pumps, and oscillating machines, are source of continuous low frequency vibrations, whereas electric motors or rotary pumps and turbine produce continuous high frequency vibrations. So reciprocating machines, you say, reciprocating engine, compressor, pumps, and oscillating machines are source of continuous low frequency vibrations, and these pump motors, electric motors, and rotary pumps and turbine produce continuous high frequency vibrations. So in reciprocating one, high frequency is less, but in circular one, centrifugal one like that is high. In order to design foundations subject to dynamic loads, it's necessary to determine value of G, that is shear modulus of soil, and mu, Poisson's ratio of soil. And however, estimated soil parameters as presented are useful in dynamic calculations. Mechanism of vibration for a body that is supported elastically is that it will vibrate in its natural frequency, which depends on its mass and elastic properties. Therefore, natural frequency for perfectly elastic body whose weight is W and resistance to deflection in force per unit of deflection is K. Resistance to deflection in force, resistance to deflection in force per unit of deflection. That is deflection is K and given by. So this is what it says. It's now to drive this, how to do that. Mechanism of vibrating is vibrating. We say vibration for a body, mechanism of vibration of a body that is supported elastically, vibrate at natural frequency, which depends on its mass and elastic properties. Therefore, natural frequency Fn for perfectly elastic body whose weight is W and resistance to deflection in phase force. In per unit resistance to deflection in a force per unit of deflection, force per unit of deflection is K. Fn, that's natural frequency, equal to 1 over 2 pi under root kilogram over W. General consideration in designing dynamic bases. It's very important. General conditions in designing dynamic bases. It's very, very important one. We have to see that one. For analysis of foundation blocks subject to vibrations, following should be considered in design. Foundation blocks means massive blocks. You know, to say is massive blocks actually. Foundation blocks means massive blocks, not concrete blocks. Be careful. Analysis of foundation blocks, massive blocks subject to vibration. Following should be considered: operating frequency, that is FO, it has to be considered. accompanied by credited resonance condition. Credited by a predicted resonance condition, mass must be increased or decreased, or spring must be altered constant. Even resonance amplitude is acceptable, but should not be equal to natural frequency. Normally should be kept less than equal to plus minus 20% of French of R is resonance amplitude. Resonance amplitude, that's FR. FO is no, operating frequency, natural amplitude, just 20% or less, and not should be kept less than this. Adjust base to condition to make center of gravity of equipment coincide with that of foundation to give almost a uniform soil pressure and static settlement. Static plus dynamic pressure should not exceed 75%. Static plus dynamic pressure should not exceed 75% of allowable static pressure. Increasing width of base as much as possible shall help in resisting rocking and avoiding excessive edge pressure problem. Try to provide 300 mm clearance all around machinery frame to help in maintenance of other requirements. It's seldom necessary to use high strength concrete for vibrating bases. It is seldom necessary to use high strength concrete for vibrating bases, since mass is usually more critical than strength. F-C is less than 21 P is not recommended. So let us say more than 21. Why 21 only? Subgrade evaluation and pavement consideration. Subgrade, now it's for roads we are talking. So it is subgrade now. Subgrade evaluation. Objective: all asphalt paving design procedures must start with fundamental consideration of our underlying soil conditions. Properties and characteristics of foundation soil will determine to a critical degree thickness of pavement structures which it will support. Consequently, part of this investigation was carried out to provide a preliminary information about subgrade condition in order to assist in pavement design and construction. Okay, asphalt paving design procedures must start with fundamental consideration of underlying and soil conditions, properties and characteristics of foundation soil determine to critical degree thickness of pavement structures, which it will support. Consequently, part of this investigation was carried out to provide a preliminary information about subgrade condition and in order to assist in pavement designs and construction. Method of analysis. Method of analysis. Origin, composition and properties of subgrade soils in area of trial pits were determined. Soil classification and identification is based on ASTM 2487 classification of soil for engineering purposes, unified soil classification system, and ASHU MA 41591 classification for soil and self-regency. So, classification of soil for engineering purposes, unified soil classification system, and ASHU 114591 classification of soils and soil aggregate mixtures for highway construction purposes. So, there are two purposes. It should be recognized that current methods for evaluating soil and aggregates are generally considered to be of an empirical nature. Engineering judgment therefore must be used in applying results of these materials. Subgrade properties. Subgrade properties. A subgrade properties, right? Now what I am saying here is that subgrade properties, soil classification test results, sieve analysis, that is subgrade properties. To know that what we need: soil classification test results, that is sieve analysis, atomic limits, natural moisture content, modified Proctor and soaked CBR test results obtained from subgrade samples recovered from trial pits and soil boreholes are so soil classification, we can say it is ASH2 M14591 recommendation practice for classification of soils and soil aggregate mixture for highway construction purposes. ASH2 soil classification for test tech subgrade materials encouraged encountered A3 fine sand subgrade using as ASH2 1145 score. Classification of soil for engineering purposes. So this for highway purposes, engineering purposes. Soil classification for testing the subgrade material encourages generally SP, that's poorly graded soil. Then soil classification for tested subgrade materials encountered A3 fine sand subgrade rating as Class 2 Swiss gold, and classification of soil for engineering purposes. Soil classification for tested surface. subgrade material encountered generally as the poorly graded sand. At above limit. Then we say tested subgrade materials were bound to be of non-plastic, which is considered good from engineering point of view. Sieve analysis, and this is also very important. Of tested samples, sieve analysis of tested samples indicated that subgrade material consists of granular materials. Percentage passing 200 CUR range between 1.6 and 6.7%, whereas percentage of materials passing CU number 4 and retained on number 200 are range. Then you can say sieve analysis of tested samples has indicated that subgrade material consists of granular materials. Percentage passing 200 CUR in range of 1.6 to 8.7%, whereas percentage of materials passing CUs number 4 and retail on number 200 are ranged between 92 and 98%. Maximum dry density, there is optimum moisture content relationship. Minimum dry density and application and optimum moisture content of tested subgrade material are as obtained from modified product are found. Then you can say that maximum dry density and optimum moisture content of tested subgrade material is obtained from modified product as a found ranged between 1.654 gram per centimeter cube and 1.739 gram per centimeter cube, with an optimum moisture content rate between 11.5 and 16.8%. Bearing CBR's California bearing ratio. Soaked CBR value for subgrade material was generally generally optimal to moderate, obtained due to not obtained due to decrease in resistance. SOX severe values for subgrade material were generally CW2 models. Okay, then CBR we can say SOX CBR values for subgrade materials were generally low to moderate. CBR value is objective. CBR test results and modified Proctor results are presented in annex for partnership. Now, and this is I can say so this is, let us compare this directly. This is table. What is this? Not this one, this was that one. Which file is open? I don't know which file is open actually. Why this is open here? Why is this user system? That is very heavy stuff. The summary of CBR and modified Proctor test results. This is that's slow study as well. That is also very important. You can see that let's see full, yes, okay. Sorry. So this is a table that shows the CBR results. See summary of CBR and modified proctor test results. Location, depth, the number, passing sieve, and index. You can say plasticity index, soil classification, and for both, that is EST and H2, and rating, modified proctor, OMC and MDD, and CBR at 100% degree of compaction. This is, for all, test pits, for test pits and bore holes. These are about how many tests? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's based on CBR. Now TP3, that is depth, is you can say 0 to 1.5. It says that number 4 is 100, number 10, this is passing sieve. Number 4, number 10, number 40, and number 200. Number 4 says that it passes through 100%, 100%, and 10, 100%, so 40, 96%. So 4% is balanced, so it's 200, let's say. This is 200, 4.1. Similarly, in this case, it says that TB4, which is 0.2 to 1.5, is 100, 4 number 100, this 97, 40, and 2.8 in 200. And TB6 also is passing through 100 to 100, this up to 2.5 in fact, depth 2.5, and 94 and 3.1. Then the remaining of borehole 3, so let's say for these trial pits, it's showing plasticity index, that's non-plastic. So these are all granular, non-plastic. And soil classification is ASTM B2487SP, that is soil classification ASH2, that is A3, AP. Then drilling is rating is good, and modified proctor is OMC, MDD. OMC is 14.3 and modified MDD is 1.721, and CBR at 100% of down degree of compaction, that is 0.1 inches and 0.2 inches. Then you can say number second, that's TP4. It's also SPA3 and P and good, and 14.2 okay, moisture content is higher, and 1.65 by 4 modified dry density, and 39.1, that CBR value is increased because of. Then you go, and there's no 0.02 inches. There's nothing in that, only 0.1 inches is considered. Then you can say the next one, TP6, it started in 94 in 05, 4 number, 40 number, and 3.1 SP same, and 11.5 OMC, 1.721 MDD, so 0.39.1. So if you see 1.721 is MDD, so it's 34.1 is CBR, and it's same as the other one is 38.7. So it's 41.6, and this means that this 39.1 is there, it's 860. So there's no relation to this one, I think. It's independent of this. And same thing you can see, that is BH3. This is we are getting degree of compaction, and optimum moisture count say 14.3 is optimized is 34.1. So when optimum moisture content is little different, so it little increases and it's little, it's first further down, it is down it off 11.5. So moisture content is 11.5, and when it's 14.7, 14.3, it was 34.1. No, but there's no relation now. It was 14.2 is 39.1, so it doesn't relate. So let's say, now come to BH3 borehole. If you see boreholes, then this is 0.5 to 1 meter depth. This is number 4, 99, number 10, 98, and number 40, 86, 6.7 here, non-plastic, and this is A3, so 12.6 OMC, and more MBD is 1.69, 40.6 is more. So if you go down to number 7 like this, BH3, BH5, BH7, BH, all if you see, there is variations up to here. If you see BH5, this is 97 at 40 number, 203.2. The SPNP and those the same. But in these cases, so we get actually passing, we get what we got here is class of plasticity index we get, which is generally non-plastic and draping is good, and moisture content and degree of compaction. We can understand its independent records of these for all boreholes. All. Now recommendation type of payment, let us see what recommendation payment is. What is that? Previous page is one. No. So let's say this actually. कितना ज़्यादा है यार ये. Types of payments. Taking into consideration following factors: properties of subgrade and availability of payment, material, initial cost and maintenance cost of payment, local experience in handling and construction, payment layer and availability of construction equipment. Recommended that flexible payment be considered for proposed roads and parking areas in this project. Payment design method outlined in R2 guide for design of payment structure 1993 is recommended. You can say then now it's that payment design method outlined. So this matter is represented in form of procedure applicable to design of payment structures as well as thickness of individual structure components. This method has advantages of expressing payment in terms of numerical value, which allows an easy comparison of areas. Method takes into consideration relationship between traffic and traffic loading, subgrade soil strength, climatic conditions, and properties in an abstract of defined as structural number of SN. Generally, now generally a flexible pavement cross section consists of B1. Generally, a flexible pavement cross-section consists of bituminous layer followed by crust continuously graded base course and by screened and crust continuously graze subbase course over subgrade. Selective screening and blending could also be used to cover up a higher quality base material. It should be noted, however, that pavement design is on trial, based on relative quality of various layers, starting with subgrade. A higher quality based material would result in increase in thickness of higher quality based material will increase in thickness of base material and a reduction in thickness of wearing surface. Thus, saving would be a reduced thickness of asphaltic concrete. If designer chooses to use a better quality material for road base, he can specify materials satisfying one of grading envelopes of ASTM-D 2041 or similar grading. Such materials are available from in Swaham queries. Selection of design strength values based on proposed method outlined in Asphalt Institute MS1. Thickness design subgrade CVR percentage value is defined as subgrade strength value at 90 degree of test value are equal to or greater than. However, considering results of boreholes which indicate consistency of surface materials and our experience, instances can say value of 22% at degree of compaction of 100%. The recommended use of design CMR value of 22%. General considerations. General considerations. Subgrade in pavement area shall be proof rolled by heavy vibratory roller and compacted to 90% maximum dry density. as obtained by Proctor, model modified Proctor. Subbase layer shall be compacted to 95%. Subbase layer shall be compacted to 95%, and that is maximum dry density as obtained by base course layer shall be compacted to 98% of maximum dry density. Then you can say base course layer shall be compared to 98% of maximum dry density as obtained by modified Proctor ASTM STMD 1947. You can say top of base course, two asphaltic layers shall be provided. Protection of embankment slopes from erosion should be considered, at design stage, particularly at high and super elevated stretches. If fiber materials are used, it's imperative that proper drainage ditch be provided at cut along alignment and proper surface drainage be provided at carriageway and be considered at design stage. For more, it is recommended to refer to standard specifications for road and bridges construction, dock, and earth pressure parameters. Lateral pressure vary directly with depth in either cohesionless or cohesive soils, except when backfill supports a surcharge loading. This reflects a hydrostatic pressure distribution, and it may therefore be considered that lateral pressure distribution, and it may therefore be considered that lateral pressure is due to fluid of unit weight. Lateral pressure vary directly with depth of either cohesionless or cohesive soil, except backfill supports surcharge load when it supports. This reflects the hydrostatic pressure distribution, and maybe therefore consider that lateral pressure distribution, and it may therefore be considered that lateral then we can say also this reflects the hydrostatic pressure distribution. It may therefore be considered that lateral pressure distribution, and it may be therefore considered that lateral pressure is due to fluid of unit W, such that total pressure of soil and so-called equivalent fluid are same unit weight of equivalent fluid. For cohesionless soil may be calculated as follows by means of Rankine equation. Resultant lateral force we see is equal to h square over 2 gamma k or Cp, you can say gamma k is pressure coefficient and gamma w is weight. So h square over 2 gamma w. Then we say that P is equal to resultant lateral force and H equal to vertical height of wall, K is equal to pressure coefficient and gamma W is equal to unit weight of equivalent fill weight. So for active pressure case, K is equal to Ka, gamma W is Y, gamma 1 minus sine phi 1 plus sine phi. For passive case, K is equal to Kp. Just a minute. Let me relax for a few seconds because of my rest. At rest pressure case, K is equal to Ka and gamma is equal to gamma into 1 minus sine phi. Ko is equal to 1 sine phi 1 minus sine phi. Then lateral pressure due to submerged backflow and that is high water table. Gamma is equal to total is equal to gamma is plus okay, sorry. Gamma dash W is equal to gamma W plus gamma sub. For design of thrust block in view of applied thrust forces, thrust will be resisted by sliding resistance between base and soil and by latent passive forces. Therefore, thrust resistance is equal to then you can say thrust resistance is equal to, for this is design of thrust blocks in view of applied thrust force, thrust will be resisted by sliding resistance between base and soil. Then we go to thrust resistance, that is F, sum of V plus gamma h square root 2 Kp. So F is equal to sliding coefficient tangent to 035 is equal to that. Soil parameters necessary for design of foundations for different relative densities of soil materials encountered in investigation. Source pressure parameters estimated from n values SPT. That's very important. Answer one by one. You see yourself and we discuss. Just a minute, please. Let me sit down back. Okay, then this is soil type SPT, that's n value, estimated BGP density. Then we can say if this soil type loose sand, medium dense sand, degree, we can say sand, dense sand, very dense sand. And if you go down further, so we will first interpret this. SPD is a 6 to 10 and then you have 50, more than 50 is there. That is sand soil.
Alright, so what I should say, let's understand this one very carefully, one very important point. It's not easy to comprehend in one go. We have to study one by one all these issues before reaching certain conclusion. So let's go further on this one by one. First we understand what we have really failed. And then we can say here SPT, that is 0 to 6 to 10, is very low, you can say. So its estimated book density is also little low. And also angle of internal friction is 30, while if you say when it's greater than 30, 50 is 41. So in meanwhile you can see various varying density SPTs giving different results altogether. Man's highest infinity is minus 550, that is 2000. So if we take it like that, in this way, we can say that assured cohesion is no need because this is sand and dense sand, so question of cohesion doesn't arise. Estimated angle is 41, 39, 37, 34. This is from below. Denser sand is having more angle of internal friction and loose sand is having less. So you can say it varies from 30 to 41. Loose sand and dense sand is having a little more. Medium dense sand a little more further, and sand is 37, then 39 and 41. Assumed cohesion is 0 and coefficient of friction with the soil at footing is 0.36, 0.39, 0.42, 0.46. It's moving like that. A higher angle of, you can say, angle of internal friction is higher point of, and coefficient of friction and density you can see lesser density means coefficient friction less and higher density means more particles and more, you can say is
Earth pressure coefficient CACPK, KPK, that is A, that is active passive, or we can say 0.33, and this the reverse is passive, 1 over this is passive, means 1 over K is Kp, value of Kp is Kv, and you know, in every case 0.21, 1 over 4 is 40 degrees. So Kp and Kv, their relation to themselves, you can say this is according to foundation analysis and design practical experience after Becky Hansen. So this is n values. So you can understand higher values of n is better in every case. Soil preparation, site preparation, cleaning and grubbing is very important activity from field point of view, from practical implementation point of view. Preparation of site is very big activity. Beginning of mobilization and doing that, because with that, based on that, you can start work of your project. So it's also project purpose of low profile. Means you have to prepare ground according to your requirement. So from there, even if required, you have to excavate after soil preparation as well. Let's see what's that. It's very, very important from that point of view. Site preparation is general internals prior to commencing grading and backfilling operations, stripping of surface, grading and backfilling operations, stripping of surface of natural material shall be required to remove loose debris, visible surface vegetation, roots, concrete and asphalt layers, waste and other soft, weak or otherwise unsuitable soils from ground surface. Exposed subgrade after excavation shall be scarified to a minimum depth of 30 centimeter. You know, exposed, says that scarified surfaces shall be scarified to a minimum depth of 30 centimeter. It's for what you was, scarified soil should be water conditioned, flooded with water, and growth rolled by heavy vibrator roller to improve expected soil and to check for pockets and pockets of soft material hidden beneath a thin coarse crust of material. So you can see that can just say any soft materials thus exposed shall be removed and replaced with well compacted selected materials. This is a part of soil preparation. So there are so many items involved in this. I will show some here. I'm not sure. Slab is a question. I wish that is a question. So let me repeat this soil preparation, site preparation, because this is very important from work point of view. When you go to some soil, you start this, you have to prepare all this. So it's only a brief, it is not extra. So it's even then it's better. Soil preparation. Yes. It says that in general, prior to commencing grading and backfilling operations, a stripping of surface of natural materials shall be required to remove all loose debris, visible vegetations, roots, concrete and Alright, so it says that is prior to commencing grading and filling operations, stripping off surface of natural materials will be required to remove all loose debris, visible surface vegetation, roots, concrete and asphalt layers, waste and any soft, weak or otherwise unsuitable soils from ground surface. Exposed subgrade after excavation shall be scarified to a minimum depth of 30 centimeter or 300 mm. Scarified soil should be water conditioned, flooded with water and proof rolled by heavy vibrator roller to improve exposed soils and to chalk pockets of soft materials hidden beneath thin crust of best better soil. Then we can say any material, soft materials thus exposed shall be removed and replaced with well compacted selective materials. Cut and fill side slopes, protection, you can say monitoring. It's also very important from that viewpoint. Why these people नहीं मानते यार क्या करूँ मैं लोगों का इनको पता है क्यों मैसेज भेजते हैं कि मानेंगे नहीं ये Yuvraj Singh is sending, Anuradha Kumar is sending, Roman, they are sending message for what? They know I am on video, they are just telling what to do. These people really, I am surprised, these people, okay. So, what's that? Yeah, what's this? So, this is here. Let me move through one or two pages of this and then I'll go to contrast a little because contrast spanning long, it's already 7:45 here. So cut and fill site protection monitoring. Cut and fill slopes shall be subject to wind erosion, wind erosion, wind is something else. Cut and fill slopes should be subject to wind erosion, drying and occasional slowing and in order to additionally protect personal and equipment. It's advisable that continuous monitoring of slopes be exercised and signs of failures such as surface cracks, continued sloughing or caving, etc., should be promptly attended depending on actual length of time. Slopes are
So curtain slopes were subject to erosion, drying, and occasional slowing, or the additionally product personal equipment advisable that have continuous monitoring slopes exercise and signs of failure such as surface cracks, continuing dissolving, caving in should be promptly attended depending on actual length of time slopes are exposed. Some maintenance may be required or slopes may have to be further flattened. A geotextile membrane can be used for long-term slope protection. Permanent unsurfaced cut and fill slopes around periphery of the site could be constructed in 3 horizontal, 1 vertical, 3h/1v, and which permanently unsurfaced cut and fill slopes within site where space may be limited could be constructed 2 to 2.5h to 1v, 2 to 2.5h to 1v. Fill materials should be placed on horizontal lift and then earth dikes and bombs. We'll take this later on. Let's move to suspension delays and etc. This will spoken before. This is specific point is advance warning is there and extension of time for completion. We discussed that one. Delayed countdown for authorities and rate of progress. Delayed damages and employee suspension. So let's say first of all, I'll do it again and again on this because it's very important material. So what is say extension of time for let's say for completion. What's actually in contracts? It's very important to consider this. Let's say it's very important to consider such issue. SP Seni, why disturbing me? Good morning to everybody. Finish now. Don't disturb me, please. Don't disturb me. So why extension of time for completion after all, while you are working? I think this contract shall be entitled subject to, subclause 22, 20.2 claims for payment or EOT that you call it. Extension of time if and to extend that completion for purposes of subclause 10.1 taking over works and sections are swelling will be delayed by following clauses. A variation except that there shall be no requirement to comply with subclause 20.2. Its limit claims for payment on EOT. It says that extension of time if and to extend that completion of purpose of subclause 10 when taking over work and sections will be delayed by following clauses and variation except that there shall be no requirement to comply with subclause 20.2 claims for payment under EOT or EOT. A variation, if there's a variation, there's some way that it can be considered as cost variation. It may be plus possibly a cause of delay giving an entitlement to extension of time under subclause of these conditions or delay, you can say delay impediment on prevention, delay impediment or prevention caused by or attributable to employer. Employers, personal or employers, other contractors on site, unforeseeable shortage in availability of employers supplied materials. If caused by epidemic
or governmental actions. So when determining each EOT under subclass 20.2 claims for payment and EOT, employer's representative shall review previous determinations under subclause and 3.5 agreement or determination, and may increase but shall not decrease total EOT if a delay caused by a matter which is employer's responsibility is concurrent with delay caused by a matter which is contractor's responsibility. Contractor's entitlement to EOT shall be assessed in accordance with rules and procedures stated in special provisions, if not stated, as appropriate, taking due regard to relevant circumstances. Delays caused by authorities. If a contractor has diligently followed procedures laid down by relevant legally constituted public authorities or private utility entities in country, these authorities or entities so we can say this delay or this delay and delay or disruption is unforeseeable. This delay or disruption be considered as a cause of delay under subparagraph of B of subclauses 8.5 extension of time for completion. So we can say contractors diligently followed procedures laid down by relevant let's say rate of progress. That's also a very important point. We'll come back to all these clauses later with a small little one, so that we can at least move subjects of contract also. If at any time actual progress is too slow to complete works or a section of any within relevant time for completion and or progress that has fallen or is expected to fall behind program or initial program which has not yet become program under subs clause 83 program, other than as a result of cause listed in subclause 85, a extension of time of completion, employer may instruct contractor to submit under subclause 83 program that's a revised program describing a revised method which contractor proposes to adopt in order to expedite progress and complete works, or a section, if whatever, within relevant time of completion. That's what is required now. In that case, recovery program, we call it generally recovery program, unless employer gives a notice to contractor stating otherwise, contractor shall adopt these revised methods which may require increases in working hours and or in numbers of contractors personnel and or goods at contractors and credit cost. Mm. Ah. So this is which may was that I missed that one. If these revised methods cause employer to incur additional costs, employer shall be entitled subject to subclause 20.2 claims for payment and EOT to payment of this cost by contractor. In addition to daily damages if whatsoever. Subclause 1331 variation by instruction shall apply to revised methods including acceleration measures instructed by employer to reduce delays resulting from causes listed under subclause 8.5 extension of time for completion. If contractor fails, as the damages, if contractor fails to comply with subclause 8.2 time for completion, employer shall be entitled subject to subclause 20.2 claims for payment under or EOT to payment of delay damages by contractor for this default. Delay damages shall be amount stated in contract data which shall be paid for every day which shall elapse between relevant time for completion and at relevant data completion of works or section. Total amount of due under the subclause shall exceed. Total amount due under this subclause shall not exceed the maximum amount of delay damages if stated in contract data. These delay damages shall be only damages due from contractor for contractor's delay failure to comply with subclause 8.2 time for completion, other than in event of termination under subclause 15.2 termination for contractor's default before completion of works. These delay damages shall not relieve contractor from obligation to complete works. So this is what actually something we have to understand here, or you can say again. I would say that it's not that easy to handle such issues that it says and we can, but there are many practical difficulties which for which we are here to confer with this. Every contract is different, and maybe yes, FIDIC we use for guidance, but every nature of contract is different, and it depends upon is what basis you have calculated time for this project construction time means. So why it's only this much time? That time in beginning when you sign contract, it's very important for contractor to make sure that this time is adequate or not adequate, or even if it's adequate, why reasons you require extension, and your reasons justified, and how much extension usually, that's not a formula. There's no set formula for that, because everybody is different. You are educated, you are illiterate, and then you can say that what's this, Shivaram Kumar studied at Lau, this boys high school, Ambridge Road, Virar. We do welcome, they should say, let's say welcome, Virar. What to do with this? Let us welcome this fish. What to do then? Okay, fine. And application of liquid, actually it's called liquidated damages, and this such that is a thinking means it requires total input, and input in a way that you have to justify first of all. As in, I'm from Bangalore, 5 years old, married, one son, mechanical engineer. Great to see you. Let's say, problem is that liquid dark. Great to see you. So, when you want to apply this, it's not simple application. You have to make sure also what was your input to force contractor to deliver job in time, and what input and why you did miss that input. If you believed to in beginning, why not first time, why at 11th hour when there's 25% delay in time means, did you notice internally defined time to contractor, and the contractor didn't respond within a week, or you saw notice to that contractor that there's a total delay, and if you don't recover it, and will you call in a meeting with contractor or contracts representative or manager, contracts manager, to ensure that they should speed up. If you fail to do means, there's your fault as well. But you have to notify certainly that you recover quickly, immediately, or we are going to resort to this action. You have every right to recover. I mean, this is not recovery. You can say imposition. Every right to imposition of LD for a number of days. But remember, in case contractor does it, in case contractor recovers in time in near future, then that person, contractor, shall be entitled for return of his money. Of course, no interest can be paid on that. But question is not that limited on this. Maybe you have some paying with contractor. So that's also one point. We can say that we have to do that, and we have to do that. And, welcome, should I say welcome engineer. If you want to serve notice, and in fact contractor does everything, works too hard day and night, augments resources, human resources or mechanical resources. You can say it works day and night and brings in that, or you can say reaches to program line, means recovery of lost time is made. You have to pay back recoveries of, I mean say, imposition of penalties, and then you shall become problem that time. Why did it recover? Why did it not deal with properly? So there's a definite setback. Means until you think what has gone up above your nose and eyes, otherwise this imposition of LD is not real penalty. This is not penalty. Was, you know, actually this must have been seen through by people. Are they are these people able to? That point we should keep in mind always, and that's very important point. We should not take easily everything. I'll just move on to this file just to show you. And so what can we else? Employer suspension, we have to discuss consequences of employer suspensions, payment for plants and materials and prolonged suspension, resumption of work, and then test on completion we have to discuss. So this is like that, and delayed tests like this, retesting, failure to protest test. These are all means very detailed, and employers taking over. And like this we have to discuss all these points, and I think it's all not very easy, but as well as not difficult. If you really understand construction, if you really understand contracts, means understanding contracts, and of course certain laws like Indian Contract Act or that country's Contract Act, or various procedures means how to handle, and various writings means how to write to contractor, what language, what precise references to various documents, and what way you expect response from contractors or contract specialists or qualified contract engineer. So you have to act as a contract engineer. I'm not talking of manager, because managers don't do anything better. Contract engineer means if you have a tendency, if you have a soul of a contract engineer also, I think you can better understand this question of understanding contract implication in line to constitution, or means you can say contract law, civil procedure codes, and those where it's not possible. I know the on site you can't do like administration do. You're busy on site, people are busy, and you don't think that lawyers are available there who can make long letters, and long letters are not required. What do we need? Set procedures means records are important. Records bind everybody, and if you don't make records or don't refer to records, whatever day has gone has gone. Though nobody can ask. You can't justify why there was delay. And if you constitute, you just file up documents. You document everything, and that document is reviewed by engineer and RE daily. So they cannot say it's today, this day, and I say there, and you can say that. That's very important point. I can say only this, that because it's already late, 8 to 10. I like to close this. Thank you very much, gentlemen, because I can't prolong it that way. It's already 2 hours and 5 minutes for this video. I think just a couple of minutes possibly, so I can advise something and contracts, and I'll do. Yes, you are an engineer, I know, but engineers run contracts, not lawyers, not judges, because technicalities and our contracts relate to technicalities, to engineering, and half or more documents. 70% of our documents relate to engineering, technical management, technical organization, technical input, and only basis of those we call them, use it for commercial. In our language you say, okay, this you are getting me, but just have a document on this. Actually somebody suggests that you find you have agreed it technically, but it may be useful in future. Better have a writing of this for contractual purpose. Nobody minds that. Even consultant won't mind, and engineer won't mind. as far as it doesn't go against real, it's not based on false statement, it's based on realistic. It doesn't waste that point. We have to understand very well. If we understand the point, I think that that's best one. Don't be harsh, be soft, but writing should be powerful. Writing, because maybe you are there today at that site or that project, you may resign tomorrow or go, or somebody else comes, so all your records should speak in sequence. That's called, logical engineer, or you can say worth engineer, not simply site engineer, but a contract engineer who understands contract complexities, and ultimately it's question of money. If you are because of your inactions, if contractor's money or your employer, the contractor is your employer, so your employer's money is trapped in somewhere. So this employer, you did not deliver your service to employer as a contract engineer. That's very important point. Okay, you are all engineers. Contract also requires engineers for that, and you have to suggest everybody what should be done, should not be done. That's okay. I have to see planning here also should involve to some quantification, to the quantification of valuation, evaluated views. And that's where they count, and it should be like that. And therefore, I say not only this, other engineers, quality engineers also should complete records, because so there may be some dispute, or there is something on some item, or some approvals which is not approved, rejected, and you have a clash. So I say we have to be very careful in this regard. And this is I say thank you very much, gentlemen.